In this lesson, we're going to be deepening our knowledge on adding and subtracting rational numbers. Let's take a look at the following problem. In science class, Ron recorded -3/10 degrees Celsius as the starting temperature of a saltwater solution. To complete his experiment, he needs the temperature of the solution to increase by 4/10 degrees Celsius. What will Ron record as the ending temperature of the solution? Let's answer a few questions to look more in depth at this problem. Reread the problem. By how much will the temperature of the saltwater solution increase? When we reread this problem, we see that he originally recorded the temperature at -3/10 degrees Celsius. This was his starting temperature. Then he needed to increase it by 4/10 degrees Celsius. So he needed to increase the solution by 4/10. Write an expression to show how to calculate the final temperature of the solution. So he originally started with -3/10 degrees Celsius, and then he increased it. So remember, the word increase means we're going to add 4/10. Explain how you would add -3 plus 4. So remember, when we add -3 plus 4, this isn't our basic addition because the 3 is negative. So to add these, you would need to either use the rule, and remember that the rule states if your two signs are opposite, you're going to subtract and keep the large of the bigger number. So in this case, 3 is negative and 4 is positive. So we would subtract 4 minus 3 and then keep the positive because 4 is the larger number. Or you can use a number line. Remember, when we use a number line, we start at our first number of -3, and when we add, we move to the right. So we would move to the right 4 units. So starting at -3 and moving to the right 4 units, we would end up also at +1. Or you could model it. Remember, we modeled it with positive and negative cubes or tiles. We would have 3 negative tiles and 4 positive tiles. And once those are paired up and eliminated, we're left with 1 positive tile. So regardless of which method you would use, you still get a solution of +1. Look at the number line below. If you start at -3/10, which remember was the starting point in the problem, and then move right 4/10 of a unit, where do you end up? So looking at the number line, you can see that we already have a point at -3/10. If we move to the right 4/10 of a unit, 1, 2, 3, 4, where do we end up? We end up to the right of 0, specifically at 1/10. So we can apply this to help us solve -3/10 plus 4/10 is a +1/10. Remember, when those denominators or those bases are the same, we just focus on our numerator by adding -3 plus 4. What is the ending temperature of the solution? Our ending temperature is 1/10 degrees Celsius. Go ahead and pause the video and explain how adding -3/10 plus 4/10 is similar or like adding -3 plus 4. Pause the video and write your thoughts down. Now let's find out a little bit more information. The idea behind adding positive and negative fractions and decimals is the same idea behind adding integers, like we reviewed earlier. You can use a number line to show adding the addition of fractions or decimals. So in the previous problem, negative 3/10 plus 4/10 is really simply just adding the negative 3 plus 4 to get the 1, and the denominator stays the same. And you move the same direction on a number line, starting at negative 3/10. And since our number line is divided into tenth units, so instead of just going up by ones, 1, 2, 3, 4, we have a lot more tick marks. It's divided into tenths. So we can simply just move the number of spaces our denominator is to get to that, I went a little far, to get to that 1/10. The same thing if it was a decimal. So we know 3/10 as a decimal is negative 0.3. So if we were to add that, we would do the same thing, except for our number line, we would use decimals to label, but it's still divided into tenths. Subtracting positive and negative fractions and decimals is also similar to subtracting integers. So let's think about a different problem. If you were to subtract 3/8 minus 5/8, so our bases are the same, so we're going to apply the same principle. First, you can rewrite it so it's an addition problem, or you can do it like we did the addition problem above, where essentially you're just subtracting 3 minus 5 over that 10. But you've got to remember your rule or the number line or model it to help solve that. The 3 minus 5 is negative 2. Oops, sorry, that's a 8 in the denominator. And then the 8 stays the same. And you can rewrite it if you prefer adding, because when we add, we always move to the right. But since it's a subtraction problem, you can easily do the same thing and move to the left. So you can rewrite it, or you can keep it like it is. Just remember you're moving to the left on the number line instead of the right. So pause the video and reflect a little bit on this question. How is adding positive and negative fractions similar to adding integers? And how is it different? Go ahead and write your thoughts down. And remember, it's comparing positive and negative fractions and comparing that to regular integers like 4 or negative 7. Write down some thoughts on how they're the same and how they're different. Pause the video and write your thoughts down. Next, we're going to focus on just adding negative fractions and taking a look at the example. A bird bath is filled to the top. On day 1, the volume of water in the bowl decreases by 7/8 of a cup. On day 2, the volume of the water in the bowl decreases by 3/4 of a cup. What number represents the total change in the volume of water in the bowl after 2 days? So there's a few words in here I want to point out to you. So we have on day 1 that it decreases. So decreases means we're subtracting. So it's decreasing by 7/8. Then on day 2, it's also decreasing. So again, subtracting, but on day 2, it's by 3/4. Then it asks what number represents the total change. Well, remember the word total we look at when we're adding. So let's look at a few ways we can answer this question. The first way is with a number line. So if we use a number line to help us answer this question, it says the following number line shows the decrease in the volume of water on day 1 and day 2. So we know that it on day 1 decreases by negative 7/8. And then we know on day 2, so we're moving to the left, day 2, it decreases by 3/4. So it's going down, so negative 3/4. So if you notice, the number line is divided this time into 8 units because our denominator is 8. So making sure if we're using that number line method, especially with fractions, that we have our number line divided into the correct number of units. We can also use an equation to help us solve this. So if we use an equation to help us solve this, remember we're trying to find the total. So total means we would be adding. So that's why you're going to see these addition signs. So we start with the amount of water on day 1. Day 1, the bird bath starts with no water. Then the problem says it decreases by negative 7/8. So that 7/8 is negative because it's decreasing. So the negative sign is telling us it's decreasing. So then we can find that change over day 1. Then day 1 decreases by 7/8 and day 2 decreases by 3/4. So again, they're both negative because we're talking about decreasing. So then we could calculate the change at the end of day 2. So let's answer a few questions about these two methods to help us make some more connections. So if you think about the expression negative 7/8 plus negative 3/4. So again, it's an addition problem because it's asking us to find the total, and totals want us to add. Our two numbers are negative because it's decreasing. The negative sign is representing the word decrease. So if we think about this expression, what do you need to do before you can add these fractions? So before we can add them, remember from our previous lessons, we have to have a common denominator. And remember, we find a common denominator by finding the least common multiple. Well, once we do that, then we can evaluate it. So I want you to pause the video and go ahead and solve this addition problem with the video paused, and then check back with me. So when we find the least common multiple, we find a least common multiple equal to 8. So we're going to use 8 as our denominator. Well, that won't change our first fraction. It's going to stay negative 7/8. Plus, our second fraction will change. So our denominator is going to be 8. To get our numerator, 4 goes into 8 2 times, and 2 times 3 is 6. And it's still negative. Now, in order to add this, we talked about how mathematically, we don't really like to have these two signs side by side. We would prefer to have one sign in the middle telling us to add or subtract. So we can rewrite this so that we have one sign in the middle. So negative 7/8 minus 6/8 when we rewrite that. Because that negative and positive in the middle that I've highlighted, a positive times a negative makes a negative. So that's why it changes to subtraction. So then, because I have a common denominator, then I can go ahead and subtract my numerator. So negative 7 minus 6 is negative 13. And you can use whatever method, whether it's the rule, number line, or modeling it with counters to subtract that negative 7 minus 6. Negative 13 over 8 is an improper fraction, so we can write that as a mixed number. It's still going to be negative. 8 goes into 13 one time with 5 left over. So negative 13/8 or negative 1 5/8. What quantity represents the total change in the volume of water in the bird bath after 2 days? Write your answer as a mixed number. So again, total means we're adding. So what did we get when we added? We got negative 1 5/8. Look at the problem on the previous page. What does a negative answer mean? So remember, when we talked about that word decrease, we talked about that's why those numbers are negative. So that means the negative answer, so that means the overall change, because that's what we found. When we added those two numbers together, we found how it changes over those 2 days. So that overall change was negative. Our final answer where we added those was negative. So for this problem, the overall volume isn't negative. The overall volume decreased. So when we're talking about it with this problem, that overall change was negative. So that means the overall volume decreased. How is adding two negative fractions like adding positive fractions, and how is it different? Go ahead and pause the video and write your thoughts down on this question. So depending on how you treat a subtraction problem, if you're rewriting it like I suggested above, here in purple, over here in purple, or beside the purple, if you're rewriting that, then adding the negatives is going to be a little bit different because you might end up subtracting. So you're going to be moving different directions on the number line. If you don't rewrite that, so if we left that negative 7/8 plus negative 6/8, then you're treating that a little bit different because you have those negative signs and you're adding. But you're going to move in the same direction on the number line if you're not rewriting it. How is adding two negative fractions similar to adding two negative integers? So comparing negative fractions to negative integers. So remember, integers are like -4, 7. Pause the video and write your thoughts down on how those two compare. How are they similar? So when you're adding two negative fractions and two negative integers, in both cases, you start on the negative side of your number line to the left of 0, and you continue to the left. So you get further into the left side of your number line. So you're getting further into your negative numbers, which would result in a negative answer. So let's take a look at a couple of examples. We want to subtract -2.5 minus 2.5. So remember, when we're adding or subtracting, we want our numbers not to be mixed numbers. So we're going to change these to improper fractions. -2.5 as an improper fraction is -5/2. So you multiply your denominator times your whole number and add your numerator. Minus 2.5 again is 5/2. Now that I have them as improper fractions, I need to make sure I have a common denominator, and I do. Both of my denominators are 2. So I can simply subtract the top, -5 minus 5, and that denominator would stay the same. It would stay 2. Now when we're subtracting the top, because it's negative, we need to either use what we know about the rule. So since they're both negative, we're going to add and keep the negative. Or you're going to use the number line. So you're going to start at -5 and go to the left 5 units. Or you're going to model it with the counters. You would have -5 counters and then another set of -5 counters. And none of those pair up. Whichever method you use, you're still going to get the same answer. -5 minus 5 is -10/2. Your denominator stays the same. And -10 divided by 2 is -5. Number 9, Susan's cat loses 1 1/4 pounds. Then it loses another 1/8. Number 9, Susan's cat loses 1 1/4 pounds. Then it loses another 1/8 pound. What is the total change in the cat's weight? So we want to be careful here. It's asking for the total, which means we're adding, but it says Susan's cat loses 1 1/4. So that's a negative 1 1/4. And then it loses another 1/8. So that's another negative number. So when we write this out, it's negative 1 1/4 plus negative 1/8 because we're finding the total. That's why it's an addition problem. But as I said previously, we want that positive and negative right there in the middle that I have just highlighted. We want those to be one sign. We don't want those two signs there together. So when you have a positive and a negative results in a negative. So we can rewrite this negative 1 1/4 minus 1/8. Now in order to subtract these, I need to change my first one to an improper fraction. So that would be negative 5/4. 4 times 1 is 4. 4 plus 1 is 5. And it stays negative, minus 1/8. Now to subtract from here, I have to have a common denominator. So between 4 and 8, my least common multiple is 8. So I'm going to come over here and rewrite it. And then I'm going to rewrite my problem so that I have a denominator of 8. For my first fraction, that will change my numerator. 4 goes into 8 2 times, and 2 times 5 is 10. And that fraction is still negative, so it's a negative 10/8. My second fraction already has a denominator of 8, so it will stay the same. Now that I have a common denominator, I simply need to subtract my numerator, negative 10 minus 1, and that denominator of 8 will stay the same. From here, you need to use whatever method you prefer. If you're using the rule, you're going to add your two numbers and keep the negative. If you're using the number line, you're going to start at 10 and move to the left 1 unit. If you're using the counter, the model it method, you would have a set of 10 negative counters and a set of 1 negative counter, which would leave you with no pairs to eliminate. So either or whichever method you use, you're going to get negative 11 over 8. Now the problem, we're using mixed numbers and proper fractions. So we want our final answer, if it can be, to be a mixed number, and this one can. So that doesn't change the fact that it's going to be negative. 8 goes into 11 one time with 3 left over. So the total change is negative 1 3/8. That negative tells you that the cat lost that much. So that negative is really important.